Hello everyone. Hi, this is for statistics exam 2. Well, we are going to review today, okay? So, over here I will try not to go over 75 minutes, alright? Okay, so number one, yes, in this exam you are going to see probability problems and of course this normal distribution stuff and what else? The last topic you are going to have is sampling distribution, okay? Sampling distribution of mean. So this is number one is the very last case of sampling distribution, okay? Americans spend on average of $617 per year for their insured vehicles. Assume the variable is normally distributed. Oh well, this is good news. It's already known for normally distributed population. And the standard deviation is $52. Now you take a sample of 40. Sample of 40 randomly selected insured vehicle owners. Okay, so what is going on over here? So this is a population, so American drivers over here, and they spend this much of money on average on their insured vehicles. So n equals 40 means you are going to take a sample of 40 and you take a mean of that. You take another sample of 40 and take another mean, and another mean, and another mean over here, okay? So of course there you can make a lot of samples. So here sampling distribution means distribution of these x bars, not x's, okay? Distribution of x bars. So when you take the mean of those means, get it? The mean of the means, that is the same as just mu. So therefore 617. On the other hand, the sigmas of x bar is different from sigma. So sigma divided by the sample size affect that. So divided by the square root of sample size, which is 52 divided by square root of 40, that is 8.22. Okay. Next, B. Find the probability that on the average they will spend on the vehicle insurance per year is less than $600. Okay? Alright. So this time you are going to see that probability that X bar is less than $600 among those samples. We are talking about just those samples, and not really individuals. Okay. So over here, we are going to use a calculator, and for your information, let's use just number 2 problem, use a table. Other problems, we are going to use a calculator. Alright? So, you have this. So in other words, when you have sampling distribution, X bars are over here, and the mean is 617. So X bar is less than 600, so it has to be 600 over here, less than, so we need to compute the area of this. So what do you have to do? Well, norm CDF, okay, that is 600 first number, I'm sorry, from the smallest here to the left end, so that gives you negative 10 to the 99. Negative 10 to the 99. And the next one is 600, and mean is 617, and the other one is 8.22. You put it at that, and you are going to have 0.1093. Okay, so in other words, the probability means this area. So as you write this, we compute the area, and this area is a probability. So how do you understand this probability? Well, that is roughly about 193 samples out of 10,000. Okay, roughly 193 samples out of 10,000 samples will spend less than $600 for their insured vehicle per year. Okay. The next one, this time in between. Well, same problem, but this is between 600 and 624. So, over here, 617 is right in the middle, and 600 here, 624 is more than the mean. So less than mean, the mean, or above the mean. So this area is our answer. And in order to do that, again, norm CDF. This time the lower number is what? 600, yes. If you start from the left end, yes, you are going to use negative 10 to the 99th power. But here lower number is this. The upper number is 624. Yes, same, 617 and 8.22. Yes, that one will give you 0.7835. Okay. All right, so that is very close to 78%. So I would say roughly 78%. So 78% of those samples, okay, will spend between this $600 and $624 on their insured vehicles per year. And part 2, let's use a table. So let's have your paper, okay, this one next to you, and let's talk about it. This time is about IQ scores. Yes, we all know that mu is 100 and the sigma is 15. We are going to use a table. A. What is the probability that a randomly selected individual has an IQ score below 110? Okay, below 110. So that is, it's not to, 110. So median is 100, 110 is over here. So the area is going to be this, a lot. Okay, a lot of a portion over here. Well, in order to use a table, you know that we cannot use those X scores. What do you have to do? Yes, we have to standardize it. So that means we are going to switch to Z scores. So when you switch to Z score, so that is X minus mu over sigma. So that gives you this 100 will move to 0, okay? And the sigma is going to be 1. Okay, so what are we going to get? Well, we are going to switch this 110 to Z-score. 110 minus 100 divided by 15, that gives you 0.67. So what do? Go to the table. So we know the Z-score and change it to probability. So that is our normal, our regular or usual way using this table. So 0.67, I'm going to roll up over here 0.6, find the 0.6 and move to 0.7. That gives you 0.7486. 0.7486. Okay? So that's the probability. As you see, this is a large portion of this whole area of 1. Okay, you cannot have a too small number over here for the answer. Well, go to part B. What is the probability that this time the IQ, randomly selected the individual has an IQ of between 90 and 120? 90 and 120. Of course, you know that this is the same as 90 and this. Okay? So, again, we go to distribution curve over here. This is 100, so this is 90, and this is 120 further from the mean. So area is this. So we are going to switch to z-score. So that is, once you switch to z-score, that is called the standard normal distribution curve, standard, okay? So it is going to switch to 0. So corresponding to 90 is negative 0.67. Earlier we saw 110, so that one I have memory of that, but this time switch to negative, okay? And 120 is corresponding to 1.33, okay? This one is switching to z-score of 1.33 going into this. So how we are going to use a table that is in between over here? Well, we are going to use the idea of how this table was set up. The table was set up using from the left end over here, correct? Okay, so go to z equals 1.33 and then subtract what? Z equals negative 0.67. So this portion over here is a probability is 0.9082. And this portion is 0.2514. 0.2514. See, 0.2514 is this green part. So from left hand to all the way 1.33, z equals 1.33. And then subtract all the way from the end to negative 0.67. So once you compute that, you are going to have 0.6568. So this is our probability that x is between 90 and 120. Make sense? Okay? Remember, the table is set up from the left end to the z-score. Okay. Next one, part C. Determine 95th percentile of these IQ scores. Okay, so what is this different from the previous problems? Yes, it is quite different. How is it different? Well, you are going to see 95th percentile means this person is, okay, below this person 95% people scores are there. Above this person's score there are 5%. So what is it? Exactly, this person is located here, and the scores below that person's score, that portion is 95%. So this area is 0.95. Get that? So what is z-score over here? Yes, we have to use a table. So what do you need to do? going to we are going to use the table opposite. So you go for area is 0.95. Well, you are going to see 4 decimal places. So find the closest to 0.95, which is I find the 0.9495 and 0.9505. So the difference is 0.0005. Here the same thing. The difference from here is 0.0005. So this is right in the middle, correct? Right in the middle. And now we go for the z-score. What is the corresponding z-score? That is, we are going to mix and match. 1.6 on the left and on the top 0.04. So z equals 1.64. When you go over here, this is going to be 1.65. So right in the middle, we are going to take this one as a z equals 1.645. Okay? So once you find the z-score, what's next? Of course, we have to find that IQ score corresponding to z. Okay? So what is x? Well, we go back. Z is x minus 100 over divided by 15 is 1.645. So what is that? X equals 15 times 1.645 and then plus 100. Okay? And of course, when you talk about IQ score, that's you use just a whole number, right? So that one is going to be 125. IQ score is 125. Okay? So 59th percentile, that means to the left. Okay, in order to find the IQ score, you go to the standard normal distribution curve, and we have to find the z-score first. How do you find the z? Find the area to the left is 0.95, and then go from there and then compute x, which is IQ score. Okay? D. What range of IQ scores make up the middle 50% of the population? Okay, middle 50%. So here is IQ 100. 50%, so to the right, 25%. To the left, another 25%. Make up middle of 50%. So this is the area. This area is 0.5, and we need to find IQ scores in both ends. Okay, so what do we need to do? Well, again, in order to use a table, we are going to switch to standard z-score. So this is 0, but again, the area is the same thing, 25%, 25% over here, and this is the area we are given. Well, how we are going to compute this z-score? Well, we have to go backwards as before. So this is the left side is 50%, this is 25%, so another 25% is over here, so you can say the area is 0.25, correct? Okay? This area is 0.25, so you go from there. So you go to the table, okay? You go to the table and find out. 0.25, that is 0.9587. Nope, it's not possible. Oh, it has to be negative. Okay, area is 0.25. So area is, yes, over here. Area is 0.25, which is closest to negative 0.67. 7 over here. So negative 0.67. So what is the x score? In terms of IQ, IQ is going to be 89.95. Therefore, I can say IQ is 90. Well, so IQ is 90 over here. The difference is 10. So as you see, there is a symmetry. So just 10 below the mean. So now 10 above the mean, that is going to be 110. Okay? So you are going to say IQ of between 90 and 110 will make up middle 50%. Okay. Now go for number 3. Number 3 is about probability. Okay, number 3. A fair die is rolled 10 times, x is the number of sixes, okay? So think about it. Whether you roll a die, your outcome you are interested in is this a 6? Rolling a 6. This is a success, okay? 6. The probability is what? Probability is 1 over 6. Rolling a 6. Otherwise, we don't care whether that is a 4 or a 5, doesn't matter. So this time the probability individual rolling over here is going to be 5 over 6. So you regard rolling a 6 as a success, the other one is a failure. Yes, we can regard this one as a binomial probability because rolling a die, each time you roll a die is going to be an independent case, okay? Independent event. So when you do that, the p is 1 over 6. Let's use a decimal. Write the possible values of x. So roll a die 10 times. So random variable x, what are the possible values? That is, you never have, okay, there is a possible that you never see a 6. So that means x equals 0, 1, 2, 3, 4, 9, 10. Maximum of 10. Okay, those are the possible x values. And the probability here, p is 1 over 6. And c. Let's compute the probability of this, getting exactly 1/6. So exactly 1/6. 1/6 over here. So that means probability that x equals 1. So it's pinpoint x equals 1. So we are going to use binom PDF. How we are going to set up? Yeah. The number of trials, that is 10, and success is 1 over 6, and we are interested in just 1 over here. If you just in case you are interested in, okay, I want to do it by hand, so that means combination